Welcome to e-Padasala program for PG students of computer science. Today we will be looking at microcontrollers and embedded processors. In this module, the objectives are we will be looking at the definitions of embedded systems and we will be looking at the architecture of embedded systems and what is the advantage of embedded systems and the difference between microprocessor and microcontroller will be discussed, and at the end we will be listing some of the examples of embedded systems. So, when you are looking at the definition of embedded system, an embedded system is a system which has software embedded into computer hardware, which makes a system dedicated for an application or specific part of an application or a product of a larger system. So, it can be anything, it can be made it for a specific application or it can be made for a part of an application or it may be a part of a larger system or it may be a product. So, rather I can call embedded system is a dedicated, embedded system is a one which has a dedicated software embedded in the computer hardware. That means, the system is dedicated for a single purpose. So, it is made for a dedicated unique purpose. So, here I can give you another definition where a dedicated computer based system for an application or a product. It may be an independent system or a part of a larger system. So, its software is usually embedded onto the memory. So, when you are looking at an embedded system, the name itself tells you that your software is embedded onto the system. But we will say that any device that includes a programmable computer, we can use that for an embedded system, or an embedded system is made with a dedicatable processor. So, an embedded system, it is any device that includes a programmable system, but is not itself intended to be a general purpose computer. So, it cannot be used as a general purpose, it should be used for a specific purpose, that is what they are trying to say. So, when the embedded systems are electronic systems, that means it contains a electronic device, rather I can call it as a hardware, where it will have a microprocessor or a microcontroller, and will always call the microprocessor or microcontroller as a CPU, rather I call it as a computer, and the computer is hidden or embedded in the system. That means, a processor is made and the code is also embedded onto that. So, I will be having a system which has both your hardware as well as software. The hardware is nothing but your computer or a processor or a controller, and the software is written dedicatedly for this particular system only. So, this can be explained very easily with one particular example, rather everybody will know, which is nothing but a cell phone. So, when you are looking at a cell phone, it can be used for a specific purpose. I am not telling you about the smartphones, I am just telling you about an ordinary cell phone. So, this is made for only communication purpose, but this particular phone will have a CPU, will have a memory, and for working purpose we have written a program onto the memory, and this will be dedicated for only communication purpose. So, we will see that in the cell phones will have a CPU, memory, programs, and which the programs which controls mainly the physical things. This will not control any other things. You cannot write your own program for doing any process in your cell phone, not for the smartphone. I am telling you about a simple cell phone. So, the program which is installed, the basic idea behind this is all your program is embedded onto this particular system. That means, the program is pre-installed. So, while you are buying a product, all the program is pre-installed and you will not be given an handle to change your programs very easily. That is what they are trying to say. So, this kind of embedded systems has some rather I can call it as an advantage or a disadvantage. So, first thing is it has limited processing power, that means it is made for particular dedicated purpose, then it will do only that particular task, it cannot do some other purpose. For example, if I am taking a cell phone, I cannot use the cell phone as a remote control. If I am using a remote control cannot be used as a communication device, talking device. So, the same way it has, I mean, because we have used a particular processor, we have written some code onto that, it will do only dedicated work, it cannot do some other thing. So, this is one limitations, rather I can say it is dedicated purpose, and the advantage is it requires only a less power. That means, the electrical power which needs, the battery power which needs will be very less. It is an advantage, and the limited data storage. So, the data storage in the sense the memory requirement or memory available on this kind of system is very less. Why? Because we will be writing already the software which has been embedded over there, we will be using it only. So, we will not be writing anything onto that. So, we will not be requiring any of the extra data storage or any of the extra memory. Because of that, it will be provided with very less data storage. But this system has the advantage of it has a very high intelligence. That means, if I am looking at a toy, maybe that is an embedded system. So, if an electronic toy is called it as an embedded system, where it will have a intelligence. For example, if it is a robotic, I mean one particular device, I can call it as your flying object, any of the flying object or a flight or a car, remote car. So, if I am looking at a remote car, it will be having a remote which will control that particular car's movement. So, the system should have an intelligence to accept the signal from the remote. So, now the system, whatever the system I am using it as an embedded system, I need to have certain intelligence onto that. So, if I am giving certain comments, the system should understand and interpret it and process it. That is what they are trying to say it as intelligence. So, it can be configured, it can be personalized, it can be programmed. So, what will be the purpose? For example, if it is a TV remote, so that needs certain process. One button should be programmed for volume, one button is programmed for brightness control. So, that way each and every thing will be programmed for a particular specialized purpose. That means, the system should understand that particular personalized options. Based on that, it will be given a program, and based on that it will work. So, it can be configured, personalized, and it can be programmed. So, basically I have given you all the outline about an embedded system, but when I am looking at an embedded system, how it looks like. So, what will be the thing which is available on the embedded system is very important. So, when I am looking at an embedded system, as I said, the processor is very important. So, I have a processor inside it, I have a CPU inside it. What is its capability is different. It may not be like your system processor, it may have certain intelligence. It may be a 8051 small microcontroller, or it may have a Atom processor, or it may have a Intel higher end processors, anything you can have it. But the thing is, it is dedicated for that specific purpose. So, there is a CPU is there, and I will have a memory over there, because if I have a processor, I need to embed code onto that. If I wanted to have a code onto that, definitely I need to have a memory. So, I have a program memory, and I need to see program is written over there, I will be having a memory. Sometimes I need to have certain data also, that also available in this particular memory. So, CPU is there, memory is there, it may be RAM or read only or random access memory, and if I have a system where I need to have a input and output device interface. So, there will be an input device which also will be connected to your CPU, and there will be some output device that also interfaced with your CPU. So, remember that this is an embedded system, this is not normal your computer system. So, because of that I need to attach certain things for my purpose. For example, I will attach some sensors to measure certain physical values, and maybe some actuators to control the physical changes, and I will be having some some other devices also, if I want I can attach to this. So, remember that this embedded system, for example, if you take your cell phone, I can have a processor inside it, I have a memory to store the programs, I can store your whatever be the messages as well as songs or anything you wanted to store it, that also can be accommodated inside your memory. And I will have a input device where I will be having a keyboard, whether it is a keypad or you will be having a touch screen, whatever be the thing I will be having it. And I wanted to have a speaker which will be having your output device as well as your screen also, LCD screen is also there, that also will be providing you output device, and you will be having something like Sensors is nothing but maybe you will have cameras, maybe the camera will be used for taking pictures and you wanted to record certain thing, that also will be there, you can put it in vibrator. So many things which you can do it with your cell phone. So, when you are mapping a cell phone with this particular system, which gives you the more detail about this particular architecture. So, we will have a memory, we will have a CPU, we will have sensors, we will have input device as well as output device. So, when you are looking at an embedded system which should have all these things, then only the purpose will be met. But remember that I cannot write any other programs onto it, so that I can modify my system. So, when you are looking at embedded system components, as I said, it embeds hardware to give computer like functionalities. We have a embedded hardware inside it, it looks like a computer. As I told you, if it is a system, the system will have a CPU, system will have the general PC will have computer system will have a memory, will have your input device, you will have output device, you will have some other things also. So, maybe these sensor may not be available, but you will be having all these things as a primary thing with your computer system. The same way the embedded system also looks like your computer and it have all the functionalities like your computer. Now, the embedded system embeds main application software generally into the flash or read only memory, and the application software performs your whatever be the application you wanted to do it will be done over there. So, it has a embedded hardware, you have a embedded software and you it can be written on your read only memory or in your flash, so that your application is run on your this particular machine. So, when you are looking at this system, we have gone through your overall architecture where CPU is there, memory is there, your input output devices are there, but basically when you are looking at a system, we will be bothering about how all these things are coordinated, who will be monitoring all these things. So, we know that the OS operating system monitors all the all the devices properly, it coordinates so that it the system process the data and it gives you the output. The same way with your embedded system also will be having an operating system, but this particular operating system is different from your normal operating system where we will be having a real time operating system. So, this real time operating, because all your embedded systems are real world products, it needs the operating system which will be having a much better capability than your normal operating system. Because of that only people will go towards this kind of real time operating system. So, which supervises the application software running on the hardware and organizes and access to the system resources according to the priorities and timing constraints of task in the system. So, you just see that this operating system which monitors the hardware as well as the software and organizes the system resources, access to the system resources, that also it does, and the priorities, based on the priorities the task will be assigned. So, the basic difference between your normal OS and this real time operating system is it schedules the task with priorities, whether it may be a static priority or a dynamic priority. So, what I am trying to say here, the static priority is whatever be the job it will be running it will be scheduled with already priorities, maybe process 1 is topmost priority, process 4 is the least priority. So, that way it schedules the task, but sometimes because of the real world operating system we need to change the priorities also. So, by the time this makes the priority will be given dynamically. So, the dynamic priorities also will be assigned to the task of your system through your real time operating system. There comes the difference between your normal OS and real time OS. So, the dynamic priorities will be fixed by your real time OS. So, that is also needed when you are looking at a real time system. So, now just look at over there, we have discussed about embedded system and embedded system architecture, and we have gone through it. In that we will be having a hardware, we will be having a software. So, your software is embedded onto your hardware and the whole overall process is monitored by your operating system, that too your it has been done through your real time operating system, and this real time operating system works based on the priority wise. That means, dynamic priority or static priority will be assigned during the application while it runs this particular process. So, now when I am looking at CPU, we will be saying that it is for a dedicated purpose. So, if it is for a dedicated purpose, the operating system, I mean your CPU may not be of a very high capability. So, we need to see, if I am looking at a normal remote control, where I do not want a processor like your laptop which has. So, maybe we need to have a processor, it needs to have certain intelligence, because you wanted to switch off, you wanted to switch on. At least these two should be known to your system. So, definitely it needs to have an intelligence. So, because of that we need a processor, but it need not be of a very high end processor. So, I can go ahead with a simple microcontroller. Sometimes I wanted to have something like your smartphone. So, we know very well smartphone is not requiring like your remote control. So, remote control needs only on and off switch, or you wanted to control something. But when I am looking at a smartphone where I need to have, the smartphone is meant for communication purpose, we are using it for different purpose, but what I am trying to say is, with that smartphone I wanted to have so many functionalities, I wanted to work in that. So, by the time I need somewhat really a good processor into it, I do not want to I mean a simple processor into it. So, rather I can call as simple as a microcontroller, high end processor I can call it as a microprocessor. So, when I am looking at the intelligent CPU to your embedded system, I have two kinds, one is microcontroller, another one is microprocessor. So, when I am looking at, first we will see that how the microprocessor will look at and how the microcontroller will look at. So, if I am looking at a microprocessor, it is actually whatever be the processor we are using it, 386 or 486 or Pentium processor, all those things, 8085 or 8086 or Z80. So many processors are there, these are all comes under your microprocessor. So, this microprocessor, otherwise we call it as a CPU, where which contains only the CPU, that means only the processor. Microprocessor has only the processor, and it is not having any random access memory, or it is not having any read only memory, or it is not having any of the IO ports. It has only a processor. So, that particular processor is, but the processor is having a very high capability. So, this is the advantage of a microprocessor, but remember that if I have a microprocessor, I will call it as a general purpose processor. So, if it is a general purpose microprocessor, I will name this as a CPU. So, if I have a CPU, if I wanted to do a system, whether it is an embedded system or a normal computer system, I need to attach externally a random access memory, read only memory, IO ports, your timer or serial COM port, or whatever be the extra fittings, I need to attach it from the outside, so that it works like a system. Whether I wanted to make an embedded system or I wanted to make a computer system, I need to attach externally, but it is very powerful. The thing here over is, it is general purpose microprocessor. You can do any work on this particular general purpose microprocessor. It can be used for any purpose. If I am writing a code onto that, any code I can write it, I can place it so that it will work. I can call this is a computer system, because I can do anything onto that. When I am looking at a microcontroller, it is completely different from your microprocessor, where I will have a CPU, I can call that as maybe a mini microprocessor, then I will have a RAM in it, I will have a read only memory in it, I have IO ports in it, I have a timer in it, I have something like analog to digital controller, and some of the peripherals which we may need it may be available with all those things. On the chip with your microcontroller, we have all these things in it. So, if I wanted to make an embedded system, I am not looking at the other peripherals, I can look at only this microcontroller, that is more than sufficient. But the thing is, the capability is less when I compared with your microprocessors. So, when I am looking at microcontroller, because I have a memory, I have a IO interface ports as well as timer, this can be used for simple applications. So, no need to get some other things which should be attached to that, so that I can make it my embedded system. So, if I wanted to make a simple embedded system like a toy or a sensor based system, or I wanted to make maybe a door opener, or I mean remote controls, or anything I wanted to make it, this microcontroller is more than sufficient, because it has all the peripherals in it. You just see that it looks, the microcontroller has a CPU, it is a single chip. Onto the chip I have a CPU, I have a RAM, I have a read only memory, I have IO port, I have timer as well as serial communication port. This is for sending a data or receiving a data serially, and maybe IO ports, maybe parallel ports will be available over there. I will be using these ports to read and write data from outside. Okay. So, if I wanted to burn only a simple application, if I am making a very simple embedded system which needs only a lesser capability of my CPU, then I can go ahead very well with my microcontroller. If I am looking at a smartphone like kind of setups where I need so much of capabilities, so by the time I may go for some higher end processors. Okay. So, if I am looking at a simple embedded systems, I can very well go ahead with only microcontrollers. That too, these microcontrollers are very cheap, it requires only very less power and the capability is also good. So, when I am looking at this system, I will be looking at the OS also. So, as I said, the OS is very important with this embedded systems. So, when I am looking at OS, I will call here RTOS, which is nothing but real time OS. So, when I am looking at real time OS, where I will be in this particular OS, what it does is it enables execution of concurrent processes or threads or tasks. Multiple threads can be handled by this RTOS. So, it provides a mechanism to let the processor run each process as per the scheduling and do the context switching between the various process. So, the scheduler is doing all the jobs like normal OS, as well as the priorities also assigned. Based on the priorities also the system is scheduling the task. So, it sets the rule during the execution of application process to enable finishing of a process within the assigned time interval and with the assigned priority. So, this is more important than all other things. So, when I am looking at priorities also, the dynamic or fixed priorities is assigned, but all the tasks are scheduled to finish within the time interval. So, that is what it will target. So, the RTOS will be useful to schedule multiple tasks, multiple threads, and with context switching or without context switching, and all the works will be assigned and done within the given time interval. This is very important when you are looking at with your real time OS. So, the embedded product uses a microprocessor or a microcontroller to do one task or it will do only one task. That means, this embedded product or embedded system is meant for doing only one task. It will not do any kind of general purposes. So, there is only one application software that is typically burnt into your read only memory. So, as I said, the embedded system is dedicated for a particular purpose. So, I cannot write some other software. So, what people will do it is, they will write the software, they will burn that particular software in the read only memory. So, once if I have a read only memory in the embedded system which has the software, when I am switching on the system, the software which is available in your read only memory is loaded onto the system and it works. So, no need to have a random access memory over there many times. That means, the we are not in a position to need more memory space over here, because we will not be using for some other applications. We know very well this is for dedicated applications. So, whatever be the application, you will write a code which will be burned onto the read only memory and it works from that. So, we will not given any of the handle to modify your programs unless otherwise the manufacturer will do it. So, a PC in contrast with embedded, so the personal computer is completely different from your embedded system. It can be used for any any applications, it can be used for any process, any number of applications. Only thing is, you need to change your programs. You can write it, you can run it on anything. But if I am looking at an embedded system, it is dedicated for a single purpose and the code is already written and it is burnt onto that. So, we will be using that particular system for only that particular purpose. This is the advantage over your embedded system. And remember that for the PC we need a microprocessor of high capability, but for your embedded system, based on the requirement, we can go ahead with the low end processors which will be very less also, with the cost is also very less. I have given you all the basic information about embedded system. Now, we need to look at some of the examples for your embedded systems, which will be used in your home, will be all your home appliances based on only embedded system. Example is your telephone, your security systems, your door openers, answering machines, your TVs and your remote control for your TV, maybe your camcorder, your video games, your cell phone, your musical instruments, your sewing machines, your toys, maybe your camera, maybe your exercising equipment, maybe your microwave oven, maybe your washing machine. So, many things I can tell you with the examples at home, and with your office you will be having computers, you will be having fax machines, you may have laser printer, you have pager, maybe you will have a copier. So many things which will be using it with your AC machines, which will be controlled with your AC remote control, that is also one of the example for your embedded system. And when I am looking at your automobile industry, where the automobile industry is basically depends on only embedded systems. All your cars will have all the controls through only your electronic equipments through your embedded systems only. So, your engine control, your airbag, your instrumentation, your security system, maybe you are entered, maybe your music player, your climate control, your cell phone, and your maybe your keyless entry, all those things can be done, used, implemented through only embedded system only. So, with typical example, maybe a car may have maybe the engine as well as your wheels will be of mechanical type, but all the controlling equipments is completely dominated by only embedded systems. So, I think I have given enough introduction about your embedded system. Now, this is the time to summary what I have covered in this particular lecture. I have given you the outline as well as definitions of embedded systems. I discussed about the architecture of an embedded system. Maybe I discussed the difference between microprocessor and the microcontroller. Here we have listed some real world examples of embedded systems. This lecture would have been given you certain introduction regarding your embedded systems. Maybe in the next lectures we will be looking at how we will be making your embedded systems and which will be very useful when you are designing your embedded systems. Thank you.